Alright, number 24 says state an interval of time when the particle has positive acceleration but is slowing down. So let's take a look. That's going to happen when the acceleration is positive and the velocity is negative. And so we just need to look at our sign chart that we made and determine where do we have a positive acceleration and a negative velocity. And so that happens from 3 to 4 and from 4 to 5. And so continuously on this interval from 3 to 5, we have this situation. So again, we need a positive acceleration and a negative velocity. And that's going to happen when 3 is less than t. In number 25, they want us to state an interval when the acceleration is negative, but the particle is speeding up. And so we're going to have a negative acceleration. And remember that if the particle is speeding up, that would mean that the acceleration and the velocity have the same sign. So acceleration and velocity have the same sign. So that means that we also need a negative velocity. So let's go back and look at our graph and our sign chart. And so we can see that on the interval from 2 to 3, the acceleration is negative and the velocity has the same sign. It's also negative. And so in this case, the acceleration is negative and the particle is speeding up. And that's because the velocity and the acceleration are working together. They're not working counter to each other, and so they're acting in the same direction. In number 26, they ask, what is the particle's acceleration over the time interval from 3 to 4? So from 3 to 4, we have our velocity function graphed, and when we ask what is the acceleration over that interval, we're asking what the average rate of change is. In other words, what the slope is. And so we're going to calculate the slope over the interval from 3 to 4. And so at 3, my velocity is negative 10, and at 4, my velocity is negative 5. So let's make that calculation. So the average acceleration over that interval, and actually it's constant acceleration, and so we could just call it acceleration, but it's going to be negative 5, which was the value of the velocity at time t equals 4, and we're going to subtract from that negative 10, which was the velocity at time t equals 3. And so we end up with a positive 5 over 1, and that means that we have an acceleration of 5 units per second squared. In 27, they ask, what is the particle's average acceleration over the entire 5-second time interval? And so if you think back a few minutes ago, we did a problem where we found the average velocity over the entire 5 seconds. And what we looked at was displacement over time. In other words, the end location or the end distance minus the beginning distance divided by time. We're going to do something similar here. And so let's go back to our graph. So in terms of finding the average acceleration or average slope over this 5-second interval, I need to look at the difference in the velocities. The velocity at time t equals 5 and the velocity at time t equals 0. We'll subtract those, and then we'll divide by 5 seconds, and that will give us an average acceleration. So acceleration as a function of time, average, is equal to v of 5 minus v of 0 divided by 5 minus 0. And so v of 5 is 0 and v of 0 is 5. So we have 0 minus 5. divided by 5, and this gives us -1 units per second squared. And then finally, number 28, they ask over what time interval is the particle's velocity decreasing at a rate of 5 feet per second every second. And so, in other words, where is the slope going to be -5? So, looking at our sign chart on our graph, we can see that we have two intervals where the acceleration is negative. And we just need to decide where the acceleration is going to be -5. So on our interval from 1 to 2, we have a final velocity of 0 and an initial velocity of 5. And so if we calculate our average rate of change or average acceleration over this interval, we have 0 minus 5 divided by 2 minus 1, and that does indeed give us a -5. And of course, on the interval from 2 to 3, we have a final velocity of -10 minus an initial velocity of 0 divided by 1 second. So this is -10 units per second change in velocity. And so we're going to be looking at the interval from 1 is less than t is less than 2. And that is the interval where the rate of change of velocity is -5 meters per second.